Yes, I have used the Kinect, and although I don't use it in my home with an Xbox device, I mainly purchased it and used it primarily for investigating opportunities for HP within the digital signage and retail space of leveraging Kinect for an interactive experience with end consumers. Yeah, if you look back, and you mentioned four different kind of, I guess, categories, but if you look back at where the computer industry has used historical user interactive devices like a mouse and keyboard, and there's even offshoots of that, like trackball mice and other things, it is to some extent unnatural. It's adapting the human to the way the computer wants to receive information. The bridge then has happened to where now everybody is familiar with touch, which is a form of natural user interaction. We use it all on our mobile devices, and you're seeing it more and more prevalent in retail. So a lot of times people I've seen this, walk into retail stores, and they'll touch a digital sign expecting it to react to their touch, and it may not because it doesn't have touch there. So the next evolution of this natural user interaction from touch is more interactions with gestures and voice and even other things like biometric information that you can use from the user just to make it all very, very natural and automatically identify who the user is, maybe facial recognition, be able to respond to their voice, and be able to respond to their body language and to their actions. A lot of areas of improvement. I mean, there's some fundamental things that are even as basic as health, right? We're all sitting in a doctor's office, none of us wants to interact with a touch screen while we're waiting for that doctor to come talk to us because everybody around us has the flu, right? We can use our body language to interact with the device and make it more natural. So I think the two primary things are being able to use gestures. It's sort of this ability to just do things without having to actually go approach the device, to do things at a distance, and it could have advantages everything from healthcare and operating rooms. It could have advantages in the home, helping us cook or helping us change TV channels while we're folding laundry. It can allow us to do basically anything at a distance or up close to these devices in a very natural way without having to really think about that we're wanting to go move the mouse in a certain way or hit a certain key on the keyboard. And over time, the computer will respond more and more naturally, just like the two of us are having conversations. And if I hold up my fist like this to any of you, you may step back and say, hey, Kent is getting passionate or getting upset about something. Well, if you do that to the computer can eventually know that type of thing and react more naturally to users. Speech is a whole other area. And I see both speech and gesture is in its very infancy as far as being able to deliver on user expectations. But as you've seen, touch and other interactions have grown and matured over time to now it's much, much quicker response. It works more as we expect it to, and that's a combination of improvement in technology and training the human to know how to interact naturally with the device. So I think all of that plays into how this will evolve and allow all of us to use these compute devices very effectively and much more naturally to do exactly the tasks that we want them to do. And a lot that goes into adopting these technologies and where they will be adopted. The way I think about it is the most natural user interaction is with my vehicle. Okay, and I happen not to tout Ford, but I get in my Ford Explorer, which is running the Windows Sync technology, and I am starting to and I've had several generations of this technology, and I am starting to be able to talk a little bit more naturally to the device and be able to do things safely while I'm driving, like call friends, or check my navigation, or check the weather, or whatever while I'm driving, and multitasking. So I think automotive is a great place where this will start to be adopted. I think other things like medical and certainly in retail. Now my expertise is focused on retail and how we can take this technology into retail. The problem with retailers right now is we've had this whole thing called a recession, where retailers are struggling to buy new technologies, but they're coming out of that, and they're wanting to have technologies that enable them to develop more loyalty with their end consumer, with their customer, to allow them to deliver the product to that customer more effectively, and allow them to essentially save money by not having to have a lot of either people in the store, more associates in the store, or more printed signage in the store. So all of this thing around digitizing everything, digital signs and interaction, natural user interaction, will improve those efficiencies. The question is how quickly will this be adopted, and for a wide-scale adoption in retail, it's going to be a good 3 to 5 years, I think, before we really start seeing these whole natural user interfaces really taking off in retail above what's happening today around touch. So it's still a little bit out there. I mean, retailers are adopting touch in mass. Natural user interactions like gesture and speech are going to be delayed, and I think part of that is technology. Part of it is really there's no solid standards around how these natural user interactions happen. I have to give specific voice commands to my car, but I know those voice commands. If I had a microwave or a television, the commands would likely be different, and so it takes a little bit of learning on my part. So I think that what's needed is really some standards around gestures and voice and all of that to really help this take off, but it will eventually happen.
All right, you talked a little bit about it, but do you think that there are any other barriers to effective implementation of NUI?
Barriers of implementation. One of the challenges that I see specifically with the Kinect, and you guys have run into this, is, and it happens with a lot of technologies that we're struggling with today, is it generates a lot of data, right? I mean, it literally floods the USB 2 bus with all of this data that's coming in, and then it's up to the software to parse through all that data. Well, I see that as a challenge because now all of a sudden you need a PC today that runs a digital sign, for instance, is trying to keep up running very high, rich content to that sign, 1080p content or interactive content, and that sign may be touch or gesture or whatever. So when you add this natural user interaction stuff like speech recognition and gesture recognition, that takes some processing power. Now, over time, that's going to be improved by bigger buses like USB 3 and other technologies to help it process the data faster. But I see that as one fundamental limitation, that it just generates a lot of data that has to be processed. Another way to offset that would be move some of the algorithms from software, like in the Microsoft OS running Kinect Windows, up into the device, so it's hardware accelerated and can do some of the filtering interactions actually up in the device. So that's one barrier. I would say cost is another barrier. So a Kinect device is $300. That's not cheap. Retailers are not going to deploy. If you think of like a Walmart, they would need probably 10 or 20 of those per store, and you multiply by the number of stores. That's a cost barrier. So, but that'll come down over time. Integration is probably the third thing. Kinect is this sort of separate. I'm not saying it's ugly, but it doesn't look integrated like you have today with touch technologies. So the ability of integrating that Kinect device into, let's say, a 50-inch display in a seamless way, so that you both reduce cost and you make it easier to deploy. You don't have wires and all of that. So I think that's probably a third barrier that needs to happen. And I had a fourth one, but I'm blanking. So I think there are a lot of barriers, but I think over time these are just going to slowly start coming down. And folks like ourselves, like HP, are really looking at how to best deploy these technologies, even in pilots with potential customers, to help them, both them and us, through the learning curve of what works and what doesn't with our mutual end customers, the retailer, right?
All right. Finally, could you talk a little bit about the benefits of applying facial recognition to Kinect? I think that was something she was particularly interested in learning about.
I love the whole topic of facial recognition. There's a lot of things you can do with that. So there's a couple of scenarios I'll talk about, and feel free to kind of take me in different direction. But For instance, an associate in a retail store or an associate in a hotel lobby, with face recognition now, they can just walk up to the terminal and start using. They don't have to do a a fingerprint swipe or a smart card swipe. So for security reasons, you can instantly identify the associate. There's a lot you can do with facial recognition as far as even where the eyes are on the screen, right? What parts of the area that people are looking at and are of interest. So if everybody walks into a Walmart and they have digital signage everywhere, and everybody's looking at the upper third of the screen where some new cool video is playing, Walmart will know that, hey, that information is important. I think also with facial recognition, it makes it easier to pull a lot of things together. So think of the day where you maybe have a cell phone and you're logging in for the first time and it sees you. It can automatically go match that information to your Facebook and your LinkedIn and your Skype account and every account that you have out there with your picture, pull it all together instantly, and now it's you all together on your phone. You didn't have to go set up all these accounts, automatically. So that's a usage case. So I really think I think the two big kind of segments are security. How do we better use the facial recognition piece to provide a better secure environment, a secure experience, as well as then the second thing is more of a networking or more of an ease of use of being able to use my information and my face to better communicate and more easily communicate with all my friends and business associates through things like Skype and Facebook.
I just had a quick question. Besides touch, do you think the Kinect is the driving force of this NUI integration, or is there some other device out there that we don't know about that might be pushing it?
Competitor.
I'm blanking. I've looked at this, and there are a couple of companies out there that do devices like Kinect, and you can just Google them. I'm just blanking on the names. The thing that Microsoft has going for them with Kinect is they already have a pretty good installed base with Xbox, and so that user base, and I forget how many. It's like close to 1 million or something. Maybe you guys know the exact number of users on Kinect if you've done your research. But if you think of all those users that now you can tap into their experience with Kinect on Xbox into the experience in the store, Microsoft has a bit of a head start there. So I'm not saying they're going to win the race. And HP typically looks at a broad set of technologies and picks the ones that will likely win the race. But they've got a great start. I think they do need to work on, as well as others need to work on, just the ability to process all the data that comes out of these things and do it with less CPU horsepower required, and do it in a much quicker and a smoother manner than it's happening today. So it's interesting. Education isn't my forte. We have some teams within HP that are very, very focused on education. And as you mentioned, cost in education is just the huge problem, right? So HP has a product called multi-point. I'm blanking on it. It's with Microsoft multi-point server, multi-seat is what it's called, where you have a single desktop and you connect all of these students' PCs into that single desktop, either using Ethernet or USB, depending on which you choose. All right, and the reason that's so effective, and I'm getting a little bit off topic, but I'll come back and try to answer your question. The reason that's effective is because now I only have one PC that I have to buy with one server license. It's a very low-cost license that's targeted at education, and I have very dumb terminals, essentially pucks, in front of the student with a display. So the cost of this thing now lowers to less than like $400 a student, right? $400 or $500 a student if you do the math. You add Kinect in there, and you're right. The Kinect today is $300. That totally throws that cost burden out, or cost burden off. So education is going to be a challenge in adopting that. They might do it maybe in one per classroom or something like that. I can think of things like, maybe a gymnastics training or some sort of lab training or something like that where you actually have to use your hands or use your body in a certain way. And you have one sign in the lab and do it that way. but that's probably not as effective as having something at every student's terminal. So my point earlier, I think, is still valid in that we have to not only lower the cost, but figure a way of how to integrate this in, similar to like what touch has done today, right? There's I'm guessing probably 10% of the displays, 8 to 10% of the displays that are out there now are being manufactured with the capability of having integrated touch, right? So we don't have that with gesture and speech today, although I guess you could argue that a lot of them that have, a microphone capability would have the possibility of doing speech recognition. But really with Kinect, it brings you three things, right? It brings you RGB data from a video camera. It brings you distance data with an infrared source, so that you can do things like distance of the device, and then with the RGB data you can map in skeleton information. And then it brings a microarray that lets you hone in on audio signals, right, and filter out what information you don't want. So all of those three technologies being able to integrate it into a display, and what Microsoft did, they tuned all of that technology such that the source and destination of like the infrared device and the microphone arrays, they're all very specific discrete distances that they can highly control. Well, when you start integrating that into panels, some of that changes. So you have to be mindful of how that integrates with the panel. So I think it's those two things. We've got to lower the cost, and we've got to get it integrated into mainstream products. And then the third thing is the software has to catch up, right? If you think of Microsoft and Windows 7 was not a very good touch experience, right? Compared to like iOS, right? Windows 8, and I don't think I'm saying anything confidential, but Windows 8 will be targeted more at touch and starting to adopt some of those more natural user interaction environments. So I would say that really the third thing is a combination of the operating system adopting and catching up with the capabilities of things like Kinect, and the applications connecting and catching up. One of the things I would suggest is, I don't know if you've done this, Windows 7 has built-in speech recognition that you can do commands that I could not get that working very well with Kinect, as an example, right? It was a very poor experience compared to just the microphone I'm using on my head now. So there's some work that both Microsoft and the ecosystem needs to do to make all that integrated and a better experience.